Hello all, this video is on using soil NPK sensor with Raspberry Pi 4. The soil NPK sensor detects the content of nitrogen, phosphorus and potassium in the soil, and it is RS485 enabled. Total 4 wires are there, 2 wires for supply and 2 wires for RS485. Brown and black wire for plus 12 volt. We are using plus 12 volt for 1 ampere, and blue is RS485B and yellow is RS485A. We are using Raspberry Pi 4 model in this video, and a SD card is loaded with the latest OS, and we'll be using VNC server for headless operation to connect with the PC. One RS485 to USB converter is used to initially check the NPK values of the sensor, and then RS485 to TTL Auto Direction module is used to connect with the Raspberry Pi RxTX pins. First, let us connect the NPK sensor with the RS485 to USB module. This module is built on CS340 and you should install CS340 driver. Initially, we'll be checking in the Windows machine. Connect the power supply 12 volt and then plug in the 3 rods into the target soil. That soil to be slightly wet, and then open the QMod master software. This is the Modbus master software, and then go to options settings and set the base address as 0 and the endian as big. Big endian means MSB stored at the lowest memory address. And then again from options Modbus RTU, select the COM port, which is the COM port of the RS485 to USB we are using, and the baud rate must be 9600. And then select read holding registers, that is 0x03, that is the function code of the Modbus, and the starting address must be 0x1e. Starting from 1e, 1f and 20, total 3 address ranges. It has got the NPK values. Now click on read write, you will get the NPK values at the correct location, that is a 1e, 1f and 20. So the NPK sensor is working correctly. Now let us connect with the Raspberry Pi. To Raspberry Pi, we will be connecting the RS485 to TTL Auto Direction module. So GPU 14, which is pin 8, goes to TX, that is the UART 0 goes to TX to TX. GPU 15, pin 10, RX of Raspberry Pi goes to RX of 485 to TTL. The 485 to TTL works on 3.3 volts, so we can take supply from the the Raspberry Pi itself. So this is very important, 3.3 volt module, as the TX RX levels must be at 3.3 volt levels. So this is the setup. Now let us start the Python code. Before that, we'll be using VNC server to connect the Raspberry Pi in headless mode, so that I can operate from my PC itself. To enable UART 0, go to Raspberry config and then serial port, interface option serial port. First disable login shell over serial and then enable serial port. After this, you click on OK and a reboot is required. After reboot, you have to edit the config.txt file. Relogin and then go to config.txt file, which is under /boot/firmware. Use nano to edit and scroll down to see this last line, which is enable _UART equal to 0, which we are done using Raspberry config. After this, add this dtoverlay equal to miniuart-bt. By default, Bluetooth module is assigned to primary UART 0 and miniuart is assigned to GPIO pins. This overlay swaps the BT to use miniuart instead of UART 0. If you want more number of UARTs, you can see my previous video. Your total 5 UARTs can be enabled. Now a reboot is required. After reboot, log in again, and then you can check using this command /dev/serial asterisk, and you can see the name of the serial port enabled, /dev/serial 0. So this is the name of the serial port we'll be using in our Python script. to access this UART. Now you can use pin control, pin CTRL get 14 and pin CTRL get 15 to see the status of the pins. It should be TXT and RXT and it should not be input. So UART is enabled. Now you are set to go. Now virtual environment setup. We use this Python 3-m venv virtual environment to create a virtual environment. We are naming it as npkenv. The system side packages is optional. So inside the home py, you can see the npkenv is virtual environment is created. Now you have to activate it using this code source. The name of the virtual environment we have created npkenv /bin/activate. Now you can see it is activated. You can run this code to verify whether the pyserial is working or not. 3.5 means it is working. Again, if you are logging in, always activate the virtual environment and then work on that. Now use nano to open Python script. Let us name it as npk sensor 3, and this is the code we are going to write inside this. So import serial and time, and then we use the serial name of the serial we found and we changed in the config.txt, that is /dev/serial 0, and the baud rate is 9600, and modbus query to read 3 registers continuously. So this is the code, that is 01 is the address, 03 is the reading holding registers, 001 is the start address, and 0003 is the number of registers to read, and then finally the CRC code. CRC code is very important, and online you can calculate the CRC code. Go to this online website, CRC code, select hex and then CRC6-mod and feed in this values 0103, 001E, 0003, and then click on CRC calculate. Now you get the result as 65CD. That is, as it is big endian, you have to write it in reverse. So it is CD65, you have to write it as 65CD. That is the CRC check code. So now we have created the byte array, and inside the function we use the ser.write function to write the npk query to Raspberry Pi, and then we wait for the response, and we print the response. That is what the hex code it returns, we print it, and then we validate the response using this function. Inside this if class we verify for the whether the length is 11 bytes, and then the response 0th byte is 0x01, and first byte is 0x03, and response is 0x06. And if it is okay, we pass the values: nitrogen value, phosphorus value, and potassium value. All these 3 values we parse it, and finally we print on the screen itself value of nitrogen, phosphorus, and potassium. Now copy this code and paste it inside this nano Py script, and then control O and X to save and quit. Now you have to run this code. Use Python 3 to run this script. Now you can see the values: nitrogen value, phosphorus value, and potassium value printed every 5 seconds. So this is how this NPK values work, and the return hex code also is printed before printing the NPK values. So this is how to enable UART on Raspberry Pi 4, and then connect NPK sensor with the RPI4 and get the values. Thank you for watching.